Hello, students. Coming into 12.3, and this is where we get to do a few additional constructions. So some of the powerful tools that we've seen so far are the perpendicular bisector. And what we got to see is that constructing perpendicular bisector, isn't necessarily long, but it does take a little bit of time. So what we're going to do is we're going to use some properties, the definitions. The rhombus is the critical piece here in 12.3. So there's some really great things about the rhombus. First off, a rhombus, all the sides are congruent. And in a rhombus, the diagonals are angle bisectors. So if you think about a rhombus, just a very quick drawing here, when I create a diagonal, which would look something like this, it actually will bisect this angle perfectly. And if I do the other diagonal, which go vertically, then it bisects this angle. So that's really, really helpful property because it allows us to, well, once we have this, anytime we make a rhombus, we get these free things. And so we do have to be able to prove that this is true. Right now, I've just made a statement that it's true, but I can show you that it definitely is true using our angle congruencies. Not just that, but the diagonals of a rhombus are perpendicular and the diagonals of a rhombus bisect each other. So we also get that these are 90 degrees, and we also get that these are bisected and those are bisected. So this is a really great use of the different shapes that we have. And as we kind of look at going forward, we're going to be using the rhombus a whole lot. Let's take a look at where we'll be using it. So if we want to construct parallel lines, we can do it in many different ways. But again, the goal here is to actually construct parallel lines. Now, what we know about parallel lines is we need to have this two lines. We have to have a transversal, and we get these alternate interior, alternate exterior, anything like that. So what we can do is we can actually construct it, and I'm going to go ahead and show how to do this one very quickly. I'll do a separate recording for each of these using the compass and straight edge. But the idea is to simply take a point that's not on the line and then draw. Here, let me just grab a little bit of white space and I will go through this one kind of quickly. Okay, so here's the idea. Once you understand the idea, you're like, oh, okay, I get it. Okay, so what you do is you have a line and a point that's not on the line. These are the given pieces. Okay, so a point, and then you got this line. Now you want to build something that is a parallel line. In order to do that quickly, and you could do this many different ways, but you draw from the point down to your line. Just draw a line. So create a new line. So here's L, and you just created line K. And again, here is point P. Okay. Now that does create a new point. It doesn't matter what we call it. We can call it Q if you want to. Okay. And what that does is it also creates an angle. Now, one way that you could create this, the parallel lines, is you could take the angle that we just formed and copy the angle up here, creating the line, because then you'd have alternate interior angles are congruent by construction. So that's one way. Okay. And there's nothing wrong with that way. You will have to do a couple of different movements with your compass. So it may not be the most efficient. And that's what we're going to kind of take a look at here. Okay. So what we're going to do is we're going to remove that one. We're going to say, okay, got it. Let's come back here. And what we're going to do is we're going to take our compass and we're going to put the pokey part here at Q, and we're going to make the length come out to P, and then just keep that length coming down. Okay. So turn an arc. All right. And that will create a new point. So we have PQ, here comes R. And then put the pokey part at P and turn kind of out over in this region, and put the pokey part at R and turn over in this region. And you will create another point. We'll call it S. And then what you do is you create the line through P and S, and you've got parallel lines. And the reason is what you've done is you've created a rhombus right here. You see, and how do we create a rhombus? All the sides were the same length. This side was the same as that side, was the same as this side, was the same as that side. Four sides all the same. That's a rhombus. And one of the properties of a rhombus is that the sides are parallel. So that's how we know guaranteed that the lines are going to be parallel. Okay. Let's see. If you wanted more of an explanation, yes, you could draw a diagonal right here, down the middle. And then let's see here. Then this angle is bisected. Now, a rhombus is a parallelogram, so opposite angles are congruent. This angle has to be the same as that angle because, again, they are bisected. And that would give you alternate interior angles. Boom. So a couple different ways you could go about doing it. All right, that is how you can make a parallel line. All right, let's take a look at a few others. Let's see here. Yeah, so this is another one where they copy the angle up. They make corresponding angles that are congruent. That's another way to do it. But it does take two different tick mark pieces as you do that, just so we're kind of on the same page. That does take a little bit more. You'd have to adjust your compass twice. The rhombus, I don't have to adjust my compass at all. It's very, very quick. All right. Let's see here. Next up, we did this in class with paper folding. Paper folding is another good way, but it's not using the compass and straight edge, and those are typically the tools that we want to be able to use. Now, if you need to build an angle bisector, again, turn the arc and then turn once more from B and once more from C. So you turn first to create points B and C, then you use those points to create point D. When you draw the lines, yeah, well, I mean, this shouldn't be a huge shock, but you're going to create a rhombus because all the sides were the same. And if it's a rhombus, the diagonal that you draw in will be an angle bisector. And there we go. All right. Next up, again, these are additional constructions. You can do this with a tool called a Mira, M-I-R-A. It kind of sounds like mirror, but it's a Mira. And it's not a true mirror where you see a total reflection. You see a reflection, but you can also see through the device. And so you can position it in such a way that you can actually draw the angle bisector. That's a Mira. And you could also do that here with your patty paper. If you kind of want to do bisect an angle, go to the vertex, use that vertex, fold one over onto itself, hold it up and make a crease, and you've got the angle bisector. Okay. If we want to construct a perpendicular line, so I've got a point that's now not on the line, just like before, but I don't want to make a parallel, I want to make a perpendicular line. The idea here is fairly similar. Start at P, and then turn to make an arc. Then from that arc, turn down again. And what you're creating, once again, is a rhombus. And what do we know about rhombus? The diagonals are perpendicular. So that is how you could create a perpendicular line very quickly. Again, the rhombus, you don't have to adjust the distance when you're building that rhombus. Okay. Let's see here. Now, if you need to construct a perpendicular bisector of a segment, you do have a couple of options. Probably the quickest option is to just put your compass to be more than halfway. So like tick it over here somewhere. Okay. Then turn up and down. Repeat with the other point with the same length. Turn up, turn down, and you will create points that have to be the same length, which builds a rhombus. And then when you draw the diagonal, it will be a bisector because the diagonals are perpendicular bisectors. That is the quick way to do it. What else? Oh, if you have a point and you want to make a perpendicular through that point, then the idea is to use what you just did, but create points A and B by turning the compass first. So turn A and B, then adjust your compass a little bit longer, up and down, and you've got yourself a rhombus, and you can make a perpendicular very, very quickly. All right. We can do the same thing with the Mira. We can do the same thing with paper folding, I guess I should say. Okay. Let's see here. So if you are given a triangle and you have to construct an altitude has to be perpendicular. For most of these, it'll be pretty quick. But again, you could just take your compass, construct the altitude from vertex A. So from A, bring your compass down, turn, and then just kind of turn across till you hit the other one, right? And then use those 2 points and repeat the process. And you'll turn here and you'll turn here, and you will be able to create this line, and that is the altitude. And the altitude, though, is only to that side. So at the end of the day, you would just put in this piece right there. Here, I mean, the altitude is already given because it's already perpendicular. So you're done. That one's done. But if they give you something that's a little bit too short on one side, just extend the side, put the length in your compass, turn until you have the other length, and then repeat the process down below to form the rhombus. Drop that perpendicular, and your altitude will be right here, right there. Again, it's just the distance to the other side. All right. Very cool. So again, you got options on ways to do it, but I'm telling you that rhombus is so fast. Again, rhombus can be used for angle bisectors. Very quick and easy, but there is a beautiful property about angle bisectors. And it comes from looking at this kind of triangle. If I know that I have an angle bisector, then I can create a length. I can create a perpendicular that goes out to both of the sides, right? And then take a look. Now I have an angle that's 90 degrees. All of them have that angle. I have this angle here in the middle. So I have angle and angle. And then they share a common side, the side that comes right down the middle. So I have angle, angle, side. And that means I have 2 congruent triangles. And if I have 2 congruent triangles, then by CP/CTC, the corresponding parts of the congruent triangles are congruent. And that means these lengths will be the same. So what we're finding is an angle bisector, a point on the angle bisector is the same distance to the sides of the angle. And that's what theorem 12.8 is about. So if we had a perpendicular bisector of this segment, any point on that perpendicular bisector is the same distance from the points. Any point on the angle bisector is the same distance from the sides. So not quite the same because they are clearly different properties, but that's the big idea. Now we can use that just like we used the distance from points to create a circumcenter, which is that circle that goes through the 3 points. We could create an incenter. And the idea of an incenter is the inscribed piece, a triangle that's inside take a triangle, and we can find a circle that's inside that triangle and touches the 3 sides exactly once, which is pretty cool. All right, so those are the big new constructions, and you'll see those as you go through the homework, right? Construct segments that are perpendicular bisectors of each other. Use the properties of a kite or rhombus to construct perpendicular bisectors to each of the following sides. All right. Create angle bisectors. Again, the goal here is to use your compass and straight edge as you do it. So I'll make a separate video where I go through the constructions using the compass and straight edge, and then I'll create a separate one to that kind of goes through maybe the proof, or maybe I'll put the proofs together. I'm not sure. Maybe I'll do one video for each of the main constructions so you can kind of go, here's how I do it, and here's why I know it's true. Okay, well, that's it for 12.3. Off you go.